So the first thing we want to talk about is what happens when we have a negative a, or a negative number, or just negative 1 in front of our function. Okay? So it doesn't matter which of these functions that we're working with. What happens when we have a negative 1 in front? It flips it. Which way does it flip it? Across the x-axis. Very good. So a good one to show, if you have 2 colored pens or 2 different color inks, that would be great. So you can show the parent function and then what is actually done to it. If I start with my parent function as black or what have you, a good one to show for this is a parabola. Okay? So a parabola, by the way, where does that vertex, or what are its intercepts? 0, 0. Okay, parent function 0, 0. And then I'm 1 over 1 up and 2 over 4 up. And try to get a decent, reasonable sketch. 3 over 9 up. And this was my original parent. And like I said, it reflects it across the x-axis. So I'm going to have the same thing, but going this way. So the graph of the function is reflected across the x-axis. Make sense? Now, the thing that we didn't talk about yesterday is what happens if there is a negative within what's happening, what's being operating on that absolute value, or that x, that function. And the reason that we didn't talk about it a ton in number 2 was because we were dealing with things like absolute value or with parabolas when we first started out, and it was very difficult to see what was going on here. Okay? But let me pull up GeoGebra real quick. And I will modify my activities to have this guy in here. Okay? We're going to have a v in here. And this v is going to be positive or negative. Okay? So let's think about what's happening here. My original function is, which one is this one? Square root. Okay? So I have f and g both on the same square root. F and g are, g is covering up, basically. Okay? Watch what happens when I make this guy, the one beside the x, a negative 1. Okay? What happens if there happens to be a negative inside the operation, the function that's happening, the expression, or the, I don't know how, I can't think of the right word to put in here. But what happens when it's with that x, inside? Flips it across the y-axis. Does that make sense? Okay? So negative 1 reflects it across the y. And a square root would be a good example to put on your paper. happens to it when we are adding a number on the outside of whatever's being operated on that X? It moves it up if it's positive. So we're adding, it moves it up. You can use the word shifts, you can use the word translates. I think our book uses translates. So what function do you want to use for this one? Absolute value, I'm seeing, okay? So we have an absolute value. Absolute value looks like this. And we're going to shift it up k units. In this case, let's make k be 5 or 4, something like that. Okay, they all work the same. What happens if k is negative? Goes down. What function do you want to use for your example here? Anyone have a preference? Problem? So here's my feedback problem. If I shift it down 2 units. What happens when we add an h within what's being operated on within that function? Left and right. So which one is plus h? Left. Okay, this is the one that's a little counterintuitive. We think plus is positive to the right, but that x is with the h. To get the x all by itself, we bring the h to the other side. And that h to the other side means opposite. Move it left. Okay? So which function do we want to use here? Square root's easy to graph, right? So here's my original square root. And I'm going to move it 4 units to the left. Sorry, I'm using a different color pen, that's okay. So this translates left k units. And then what happens when we subtract h from it? Right. Translates or shifts right. What function should we use for our example here? Square root. Square root's easy. So here's my original square root. I'm going to go right 5 units this time. last examples are ones that involve fractions. Okay. So h of x is equal to some number on the outside being multiplied by f of x. Okay, we already dealt with the positive negative thing, right? But what happens when a is bigger than 1? Stretches it vertically. Okay? So think about it grabbing you by the top of your head and pulling you up, grabbing you by your hair and pulling you up. Okay? So when a is greater than 1, vertical stretch. Okay? And when a is between 0 and 1, a fraction, it is a vertical shrink. So parabola might be a good one to show on this one. If our original looks like this, when a is greater than 1, it's going to be pulled up faster. It's going to be narrower. Okay. Stretch vertically. But when a is between 0 and 1, a fraction, if my original looked like this, it's shrunk vertically, it's flattened. Okay, makes sense? What happens when a is with x? Within the operation that's being performed on it, within the absolute value, within the square root, within the x squared. Any ideas? We haven't seen it a lot. We saw it in algebra 1 briefly. Okay, let's look at this guy. Let's go back to GeoGebra. Okay, so now we're looking at this b guy. And we don't want it to be negative anymore. We want it to be a number between 0 and 1. So here's 0. Watch what happens when it's a fraction. Think about this guy as being the horizontal thing, right? So we've reflected it, we reflected it across the y-axis, right? So we want to think about it in terms of horizontal. What's happening when it's a fraction? You see that it's stretching it horizontally? It's making it go whole side to side horizontally. And when it's bigger than 1, what's it doing? Shrinking it horizontally. Does that make sense? Okay, so it's the opposite of what we saw before. Shrinking it horizontally. So when b, in this case, we were using b, I believe. Actually, it's a here, so we'll keep using a for the graph. When a is with that x within the function, and a is bigger than 1, it's a horizontal shrink. And when a is between 0 and 1, it is a horizontal stretch. So let's use that square root function. A is bigger than 1, horizontal shrink. What does that look like? Is it closer to the x-axis or above? Above. Okay. And when it was a horizontal stretch, it's pulling it closer to it, isn't it? Okay. So hopefully this chart will help you keep it all straight. Okay? You've had good exposure to this in Algebra 2, but we want to make sure everybody's on the same page, have the same opportunity to play with these functions. Okay, so here we go. Let's talk about the graph of x cubed. Okay, and let's see what's going to happen. So based on the x cubed, y equals x cubed, let's think about what we can do to make these other things happen. Okay, what will, I should have renamed this g of x and h of x probably, but what will this second graph look like? What's going to happen to it in relation to the first? Up to, okay? So every point that would be here will be translated up to. 0, 0 is now going to be 0, 2. 1, 1 is going to be 1, 4. 1, 3. Okay? And negative 1 is going to be negative 1, 1, right? Okay? So that little look there that it's doing, that little jog, and then negative 2, negative 8 will be negative 2, negative 5, right? Did not draw that well. And 2, 8 will be 2, 10. Get the general idea, okay? Got graph paper and it's not taller than you are, so you don't have to stretch. All right, second one. What's going to happen with this one? Right 1, good, up 3. Okay, so don't let it trip you out. Right 1, up 3, so every point's translated. This one is right 1, up 3. This one is right 1, up 3. This point is right 1, up 3. And we're sketching here, right? So we're not expecting perfection. We're wanting to see that inflection point, a couple points, just real quick ones that you know, and then show me what's happening. Does that make sense? No T-chart, no table of values. Okay, quick sketches here. Not looking for perfection. All right. The graph at the right is a function of f of x equals x to the 4th. The two graphs below are transformations of that graph. Find the equations of these functions. So this is what x to the 4th looks like. Notice it's a little bit flatter on the bottom, and it shoots up faster than x squared. Okay? How has g of x been transformed, or how has our original function been transformed to g of x? Got a negative. Okay, negative out in front, I agree. Why? Reflected across the x-axis, okay? So g of x is a negative f of x, and then what else? What, left 3 inside the parentheses. So, left 3 means I do what? Plus 3. That's all we're looking for, that kind of notation. We took f, we flipped it, and we moved it left 3. Okay? Everybody good with that? If you told me that this is negative x plus 3 to the 4th power, that's fine as well, because you know your original function. I'll take either answer. All right, next one. What happened with h? Negative. So h of x is a negative f of x, right? And what do we do? Left 1, so plus 1 and up 2, so plus 2. And if you want to write it as negative x plus 1 to the 4 plus 2, that's good too. Okay? Be familiar, comfortable with both. All right. What questions do you have on this slide? Okay. Compare the graphs of each of these. So this is now your parent function. Okay? So I'm taking it one more layer of abstraction away. X plus 2 is our original function now. What have they done to this? Reflected across the y. That's exactly what I want to see. Okay? How is this one different from this? Reflected across x. And good, it's left 3 more, right? It was already left 2, but now we've added 3 more, so left 3. If you want to write translated left 3, that's even better. Make sense? We can do this stuff, right? We're prepared. We know what we're doing. Compare x squared with this. Shrink, which way? Vertical shrink. And vertical stretch. If they had wanted to make it a horizontal stretch or shrink, they would have had to put parentheses around that too. Make sense? Okay. What about this one? So we've now done we're taking whatever was here and we're putting a 2x in everywhere we see x squared, right? Okay, so g of x is a 2x squared plus 3. So substitute that in so you know what's happening. Okay, so what have we done? Horizontal shrink. Awesome. Okay, and how about the next one? Horizontal stretch. That's awesome. And the previous features were awesome. You know what you're doing. Okay, so you've got your thing. A lot of problems, but a lot of it's just telling you horizontal stretch, horizontal shrink, vertical movement, 5 units up, and those things. Okay? Same thing from your sheet. Bolds and underlines are required. Thank you.
Absolutely.